Okay, so from your notes, we're starting the second chapter now, you guys, and we're going to start talking about functions. And those of you that started the vocab last night will know these definitions, but we'll go ahead and go through them right now in case you didn't get a chance. So a relation is any set of ordered pairs. Okay? An independent variable is always the first variable in the ordered pair, or the x value. And the dependent variable is always the second variable in the ordered pair, or the y value. When you're reading a story problem, the dependent variable is always, it's relying on what the value of the independent variable. That's the reason why they have their names, independent and dependent. Okay? A function is a set of ordered pairs where the x variable is paired with exactly one y variable. Okay? So you'll never find in a function where an x has two different y variables paired with it. Right? A domain is always the x values in the function. And the range is the y values in the function. So down below we have, I can't even get to it on this, but on the bottom it says, we use the symbols in the table at the right to represent the numbers of x in a set A, where x is said to be the member or element, is what you're going to put there, of A. Written as, and if you can see this in the dark area here, it's as x, and you're going to kind of a curved E. So x is an element of A, like that. Okay? So that's what that symbol means, that curved kind of E is like an element of. And then it says, for instance, 3.5, the number 3.5 is an element, and it's a funny Q because it's got a double side, and then it's got a Q there. So, and I'll go through that in just a minute. Down below we have a chart.
What did you write there?
What did you write? For instance, 3.
For instance, 3.5.
Oh,
3.5 is an element of a double-sided Q. It's like got a thick wall on it.
like a bubble.
Yeah, bubble lettered. Yep. Q. Q, in this case, if you look to the right, there is a chart. And you have Z, R, Q, and N on the side. Z stands for integers. Yeah, I know. I'm going to pull it down. Sorry, didn't cut off very well. Here's integers. R stands for real numbers. Okay? Q stands for rational numbers. So what is a rational number again? It can end. It can be a repeating decimal, but most of the time you think of it as a fraction. Okay? So fractions are a part of the rational number grouping. Okay? So that's why up here we said 3.5 is an element of Q, which happens to be rational numbers. Okay? And N is natural numbers. What are natural numbers again? Whole numbers that are what? They're greater than 0. Okay? Natural numbers are whole numbers greater than 0. Q is rational numbers that can be fractions. R is a real number. It can be any decimal point. That's what a real number can be. Integers. What are integers again? Whole numbers, and they can be negative or positive or 0. All right? Yep, naturals are positive whole numbers above 0. Yep. Okay, so similarly, every even integer, and this is an important word here, even integer can be written as 2n. Right? Because every even can be divided by the number 2. Okay? Where n represents the set of all integers. So we can write the set of even integers like this. A bracket, 2n, and then a line, and then an n with that element of, and I'm going to put that double-sided z there. Okay? And it's read like this. The set of 2n such that, that's what that line in between the 2n and the n means, such that n is an integer. I guess you don't need that squiggly mark right there. Okay, so today's lesson, we're going to be really looking at the math language of how to describe some of these things. And so you're going to see those brackets, and you're going to see letters, and then that such that sign in there. So pay really close attention as we go through this. Some of you may not have ever seen that before. I'm not sure. Okay? We ready to move on? Okay. Okay, so an example. A bakery charges $2 per muffin, and a customer gets $2 discount for every 6 muffins purchased. Which statement is true? The cost C is a function of the number of muffins, or the number of muffins is a function of the cost C? The first one. Yep, the first one is true. Okay? So you're going to want to circle that one. Because C is dependent on the number of muffins, how much it's going to cost overall. Okay? Identify the independent and the dependent variables. Well, I just said dependent is the cost, right? Okay? And the independent is the number of muffins, or M. Okay? So now we want to talk about domain and range. How many of you remember using the domain and range? Okay. So in this case, the domain would be number of muffins, right? And I'm going to write it in the math way that we do. M such that M is an integer. Okay? M's an integer, and it has to be what? What's the smallest number you can have? Even smaller than that. It can be 0, right? So it can be and M is greater than or equal to 0. So that's the domain of the muffins. Okay? Range, we're going to be talking about the cost, because that's the dependent variable. C such that C is also a member or an element of integers. Okay? C is an element of integers, because we don't have any decimal points or anything like that. Because it costs $2 per muffin. We don't have any cents in there. And C is greater than or equal to 0. Okay, that should be an equal to. And what C is even. Because they're charging $2 a muffin, right? So really, this is just a way of describing it using math, quote, ease, unquote. Okay? It's a math language. Everybody got that down? On this one, we have n as an integer greater than 2. Graph the function that shows how many elements of an ordered set of n different integers are greater than the median of the set. Okay, so I'm going to give you some sample sets right now. We're going to start with 2 numbers in the set, and that's going to be a 2 and a 5. 3 numbers in a set, and really you guys could put any number in here. 4 numbers in a set. So these are sets with this many integers in it. Okay? Yeah, I'll pull them out of the teacher's manual. They're kind of dumb. I could have done something a little easier, but. Okay? 6 could be 1 through 6. So now I'm making up my own. 7. Okay? So we want to know where the median is in each of these. So if you think about back through last chapter, I'm going to use a pink marker. My median in this would be like right here, right? Right in the middle of the two of them. Right, but I'm not actually calculating it. I want to know how many numbers are greater than the median in that set. 1. So my answer is going to be a 1 here. Okay, and the next one, my median is actually 46. Right? So, nope, I want to know how many numbers in that set are greater than 46. 1. Okay? My median on this one, on number 4, would be right between 24 and 35. So how many numbers in the set are bigger than that? 2. Okay? On the next set, my median is 3. It's going to be 2 again. And on this set right here, it's right between 3 and 4. So how many do I have larger than that? 3. And on this one, yep, same thing. Okay, so if I were to graph this, you guys, it would look like this. At 2, I have 1. At 3, I have 1. At 4, I have 2. At 5, I have 2. At 6, I have 3, and so on. Yes, it does, and we're going to talk about that. It can be called a step function or a piecewise function. Okay? So another way to describe this function in the sample is to combine it with 2 rules, and here's what it should look like if you write it down below. It should be C equals, okay, n divided by 2 when n is even. And then n minus 1 divided by 2 when n is odd.
How do you know that?
Because, like, if I were to add, notice that the number 3, how do I know that? Is because if you take the n as 3, and if I were to divide that by 2, that'd be 1 1/2, right? But we don't have a half a number above 46 here. Okay? So we're going to subtract 1 and make it a whole number. Okay? This is given to you in this case, but okay. So, I'm going to turn my page. This type of description is called a piecewise function. Okay? Because it breaks down the domain into pieces, and there's a rule for each piece. Okay? So example 3a, we are given a rule is y equals 2 to the x minus 4. And it says give the domain in the range for all the function. The nice thing about this one is they already gave it to us in graph form. Okay? So we can even look at the graph and see where our limits are. The domain in this case, all the x values, is x such that x. Now, would you say that these would be part of a real number set, a whole number set, an integer? What would you think? Real. Real, because if you notice that this is a line that goes on forever and ever, and it's like connected. When they're connected, that means it could be infinite possibilities between 2 points, right? So you can have 2.5, 2 3/4, 2.9999. So when it's connected like this, you know that it's going to be a member of all real numbers. So they'll be like this. Okay.
Wait, because you can't just
So x can be anything because it goes on. X goes forever this way, and it goes forever this way.
So then you just say it's part of all of them.
Yep. Okay. But y, however, ends at this point right here, right? At 4. So I'm going to say the range for this is y such that y is all real numbers. Oops, I put x. Y is all real numbers. Sorry, having difficulties here. All real numbers, and y is greater than -4. Because that's the lowest that y goes down to.
Be greater than or equal to?
In this case, it actually never achieves -4.
But it is on negative.
It's an asymptote. Yep.
What does that mean?
Asymptote means it will continually, just a minute. Yes, it continuously gets closer and closer, but it never touches. So if you were to take a microscope and keep magnifying it, it would never reach.
Okay.
Okay?
Other than that, that's sweet.
Okay, example 3b says find the domain and the range of the function with the rule 3x minus 5 squared minus 1. So in this case, if I were to look at a graph, and I actually have this graphed already, look at this one right here. This is the graph. You could actually put it in your graphing calculator. What is the range of what is the domain in this case? Sorry. What are the x values? All real numbers, right. It goes in both directions forever. How about y values, though? What's the minimum y value I have? -1. That's the smallest it gets. Okay? So if I'm going to write this down, my domain is x such that x is all real numbers, and my range is y such that y is all real numbers, and y is greater than or equal to -1. Okay? And we could see that really quick by looking at that graph. Yes?
Bring our calculators down.
Yeah, you can bring them in for the graph to graph with, but during tests you still can't use them.
Is there a way to get the domain?
Yeah.